Hi students, welcome to Sunil's tutorial. I am Sunil Madwani and today we will be doing this chapter called as electrochemistry. Now let's continue where we left last time. We were talking about cell constant, right? Let's see the definition of cell constant. Definition of cell constant. Right? Let's see what is the definition of cell constant. Cell constant is nothing but it is the ratio of the distance between the electrodes to the area of the cross section. Cell constant B is the ratio of the distance between the electrodes to the area of cross section of the electrodes. Right? Thus, I could say that cell constant B is nothing but L upon A. It is directly proportional to the distance between the electrodes and inversely proportional to the cross-sectional area between them. In that case, what will be the unit of cell constant? This is meter square. So it should be meter raised to minus 1 or centimeter raised to minus 1. Fine, do we get this thing there? Now, let's see. How do I determine cell constant? Determination of cell constant. I can determine cell constant by using Wheatstone network. Right? For example, if I had a cell here, here, this is the glass vessel or glass tube. You have two electrodes that are being immersed here, which have a platinum plate at its tip. Right? Now, let's connect this, guys. Let's have a resistance here. Right? Have a resistance here. Let's call this point as A, let's call this point as B. Galvanometer, and the jockey that would be here. FC. Right? So this is your solution, some solution I'm going to put in here with some resistance. Solution with unknown resistance. Right? This is your conductivity cell. Conductivity cell. Here I'm going to connect AC voltage and that's it. Right? Now let's try to see how does this work. In order to find out the conductivity of cell, I have to make sure that I use the solution that I'm going to use. I'm going to use a KCl solution which is either 1 molar or 0.1 molar or 0.01 molar. Right? So first thing I need to make sure is by using 1 molar or 0.1 molar or 0.01 molar KCl solution, cell constant can be determined. determine. So first thing I need to make sure is I need to make sure that the molarity of the solution is correct. Now the conductivity of KCl is known at different temperatures. Hence, by using the principle of Wheatstone bridge, the resistance of KCl can be determined. Why are we using this? Because the conductivity of KCl, the conductivity of KCl is known. The conductivity of KCl is known at different temperatures. The conductivity of KCl is known as different temperatures by Wheatstone bridge principle. Wheatstone bridge principle. The resistance of KCl can be determined. Resistance of KCl can be determined. Fine. Now, how do I do this? How do I find out the resistance of KCl? You have AB is a uniform slide wire. You've seen the diagram. AB is a uniform slide wire. Right? Let's assume that Rx is a variable resistance placed in one arm of the bridge. Rx is the resistance. I'll just show you my RXs, guys. Can you see this? This is my Rx. Rx is the resistance that is placed in one arm of the bridge. Rx is the resistance placed in one arm of the bridge. Rx is the resistance placed in one arm of the bridge. Now the conductivity cell is dipped in KCl solution of unknown resistance. The conductivity cell dipped in KCl solution of unknown resistance is placed in the other arm. So in one arm you have Rx, in the other arm you have an unknown resistance. Fine. Unknown resistance, that is in terms of KCl solution. D is the current detector. Right? And F is the slider contact that moves along AB. F is the slider contact that moves along AB. So that's my entire setup, right? Now, an alternating current source, AC is the alternating current source. AC is the alternating current source, right? Now, the slider contact moves along AB such that, keep moving it along AB such that D shows no deflection. I should have no current passing through D, right? The sliding contact F, the sliding contact, same your Wheatstone procedure I'm following here. The sliding contact F is moved across AB in such a way that the current detector D shows no current. That the current detector D shows no current. Right? That means the bridge is balanced. Let's assume that this occurs at point C. Suppose this is the point C. Now if the bridge is balanced, I could use the bridge principle. Therefore I can say according to Wheatstone bridge principle. According to Wheatstone bridge principle, I can say that resistance of the solution upon RAC should be equal to Rx upon RBC, right? Resistance of the solution in divided by resistance of the length RAC should be equal to resistance Rx upon resistance of BC. Now I can say that, but we know that resistance is directly proportional to length. Therefore I can say resistance of AC is nothing but length AC, and resistance of BC is nothing but length BC, right? In which case I can therefore say that the resistance of the solution, I can therefore say that resistance of solution is going to be nothing but cross multiply this length AC into Rx upon length BC, right? So in which case that's my resistance of the solution. Now from the above formula, resistance of KCl can be calculated above formula. Resistance of KCl can be calculated, right? Now once I have this, once I know the resistance of KCl, because I know length AC, I know length BC and Rx, all three parameters are known to me, then I can say that K is nothing but B upon Rx. So therefore I can say that B is equal to K into Rx, right? Thus by knowing cell constant, thus the cell constant can be calculated by knowing the conductivity. If K is known to me, this cell constant B can be calculated by knowing the conductivity of the solution. Right? So that's how you can find out the cell constant. Fine, do you get this in here? The same formula could also be used to find out the conductivity of the solution. I can say, suppose if I say that how do I determine of conductivity of the given solution, determination of conductivity of given solution. How do I find out conductivity of a solution? Very simple. Same principle I'll use. The only thing is I can say that the given solution is placed the given solution. Instead of using KCl, I'll use the given solution. The given solution is placed in place of KCl. Once I've done the experiment, I would definitely know the cell constant. Once I know the cell constant, I can change the solution of KCl with a given solution and its resistance is measured by Wheatstone principle. So in which case I can say that conductivity is nothing but K, which is nothing but B upon R. We already know B and R. I can also say that molar conductivity we had also in the previous lecture learned what is molar conductivity. Molar conductivity is nothing but K upon C, right? Thus molar conductivity can be calculated by knowing the concentration. K I will come to know from there. C is the concentration. If I know the concentration, I can easily find out molar conductivity. Fine, do we get this in clear? Next, what do I understand by an electrochemical cell? What is an electrochemical cell? A device which is used to study chemical reactions electrically is called as an electrochemical cell. It will be made up of two metal plates or carbon rods that are dipped in an aqueous electrolytic solution, and the charge transfer through the electronic conductors in metallic conduction would take place in it. So what is an electrochemical cell? It is a cell that is used to study the chemical reactions electrically. If I want to study chemical reactions electrically, the cell that is used is called as an electrochemical cell. So what is an electrochemical cell? It is a device that is used to study It is a device that is used to study chemical reactions electrically. So if I want to study chemical reactions electrically, the device that is used is called as an electrochemical cell. What is it made up of? It consists of two metal plates dipped in an aqueous electrolytic solution. It consists of two metal plates dipped in aqueous electrolytic solution. So it consists of two metal plates dipped in aqueous electrolytic solution of an electrolyte. Right? The charge transfer through electronic conductors is metallic conduction. The charge transfer through electronic conductors, that metal plates that are put, electronic conductors, the charge transfer through electronic conductor is metallic conduction, So here you are going to have metallic conduction, while through electrolytic conductors, is ionic conduction. So you will have two different conductions taking place, one through the metal and one through the solution. So that's an electrochemical cell, right? Let's try to see in detail what do I understand by metallic conduction and ionic conduction. Metallic conduction. What do I understand by metallic conduction? Very simple. When the charge transfer is because of the flow of electrons in the metal, then that is called as metallic conduction, right? If there is flow of electrons through the metal which causes the charge to be transferred from one place to another, then that would be called as metallic conduction, right? Metallic conduction in metallic conduction, the charge transfer the charge transfer is due to the flow of electrons through metal. When you have flow of electrons through metal, then that is called as metallic conduction. Next, what is ionic conduction? When the charge transfer occurs through molten or aqueous solution, then that is called as ionic conduction. That means here the charge transfer will take place due to cations and anions, right? The charge transfer occurs through aqueous solution of an electrolyte. It occurs through aqueous solution of an electrolyte. The conduction of electric current occurs through the motion of cations and anions. That is called as ionic conduction. Next, what do I understand by an electrochemical reaction? What is an electrochemical reaction? It is nothing but it is a redox reaction. I'll explain to you what is redox reaction, where reduction and oxidation takes place simultaneously. So it is a redox reaction involving transfer of electrons from one species to another species. Right? So what is an electrochemical reaction? Electrochemical reaction. What do I understand by an electrochemical reaction? It is a redox reaction. It is a redox reaction involving transfer of electrons from one species to another species. Right? Which occurs in electrochemical cells. Right, that's an electrochemical reaction. Next, what do I understand by electrodes? What is an electrode? The surface on which oxidation half or reduction half occurs are called as electrodes. Right? Electrodes do not participate in the reaction, they are inert. Right? The surfaces on which, remember, electrochemical reaction was a redox reaction. So on one of the electrode you would have reduction taking place, on the other electrode you would have oxidation taking place. So the surfaces on which oxidation half or reduction half, the surfaces on which oxidation half or reduction half occurs, reactions occur are electrodes. That's how I define electrodes, right? Which may or may not take part in the reaction. Which may or may not take part in the reaction. So that's what is an electrode, right? Okay, now when you talk about electrodes, I said there's one electrode on which oxidation will take place, there's another electrode on which reduction will take place. Now these two electrodes, that means these are two separate electrodes, they are named as anode and cathode, right? Anode, right? What is anode? The electrode where oxidation takes place. Oxidation, what do I understand by oxidation, guys? Loss of electrons. So the surface on which loss of electron takes place or oxidation takes place is called as anode. Fine. The electrode where oxidation, that is loss of electrons, takes place is called as anode. Next you have cathode. Exactly reverse of this. The electrode where reduction, that is gain of electron, takes place is called as cathode, right? The electrode where reduction, that is gain of electron, takes place is called cathode, right? Now when you talk about cathode, there are two different types of cathodes. No, cathode is done. Next, let's talk about, we did metallic conduction, ionic conduction. Okay, we've also done what is an electrochemical cell. Electrochemical cell, we said, is a device that is used to study chemical reactions electrically. Now when we talk about electrochemical cells can be further classified into electrolytic cell and voltaic cells, right? I can say that types of electrochemical cells. There are two different types of electrochemical cells. One is called as electrolytic cells. The second is called as voltaic cell. It is also called as galvanic cell. So it is either called as voltaic cell or a galvanic cell. Now let's see what is the difference between them. An electrolytic cell is the one in which non-spontaneous redox reaction takes place by passing of electric current into the solution, right? So if you have to pass electric current through the solution for the reaction to take place, then that would be called as an electrolytic cell. In a voltaic cell, the cell in which spontaneous chemical reaction takes place to produce electricity, that is called as a voltaic cell. So in one of them you have to give electricity so that the reaction takes place. In one, the reaction is spontaneous. Because the reaction takes place, electricity is produced. Fine, do you understand this? So I can say that electrolytic cell. What do I understand by an electrolytic cell? An electrolytic cell, a cell in which non-spontaneous redox reaction takes place. Reactions are made, non-spontaneous redox reactions are made to take place by passing electric current or passing electric current into the solution are electrolytic cells. Right? Next, what are voltaic or galvanic cell? In these cells, the reaction is spontaneous, right? A cell in which a spontaneous chemical reaction, a spontaneous chemical reaction produces electricity. Produces electricity is called voltaic cell or galvanic cell. Fine. So now that we know our basics clearly, let's try to see a little more advanced theory with this. Let's try to see the working of an electrolytic cell. Now I told you what is an electrolytic cell. It is a cell in which non-spontaneous redox reaction takes place through passing of electric current, right? So what does it actually do? It converts electrical energy into chemical energy. What is an electrolytic cell? It is a cell that would convert electrical energy into chemical energy, right? Let's see the working of molten sodium chloride. Molten sodium chloride. Now, working of molten sodium chloride as in the construction and the working of an electrolytic cell. Let's see the construction part of it. Of electrolytic cell. Right, A part of it would be the construction and B part I will show you is the working. Fine, do you get this thing here? Now, what does it consist of? It consists of a vessel containing molten sodium chloride with two graphite electrodes that are dipped in it. It consists of a vessel containing molten sodium chloride with two graphite electrodes dipped in it. Right? Now, the electrodes are then connected by a metallic wire to the battery. The electrodes are then connected to a metallic wire by a battery, right? And the electrodes connected to the positive electrode is called as anode, whereas the electrode connected to the negative electrode is called as a cathode. So you would have an anode and cathode. I'll just draw all of this and show to you. You and here. I'll just write this down first. Electrode connected to the positive terminal is anode and connected to negative terminal is cathode. Right? So you would have, as I said, you would have a metallic vessel in which you would have two electrodes dipped molten sodium chloride that would be present in it, and the two electrodes then would be connected by a wire to a battery. Right? Where you would have positive terminal, this is connected to the positive terminal, this is connected to the negative terminal. Right? Positive terminal of the battery, negative terminal of the battery. Right? That's your construction of an electrolytic cell. Right? Where you have, this is your carbon anode, and this is carbon cathode. You have fused sodium chloride. Right? What you will observe is that you will see bubbles of chlorine gas at anode. This is chlorine gas, and you would see a layer of sodium on cathode. Right? So that is what your electrolytic cell would look like. Right? Let's see the first part was the construction, the second part is, let's see the working. The working of an electrolytic cell. As current flows through the battery, battery acts as an electron pump. It takes the electrons from anode and pushes them to cathode. When current flows, the battery acts as an electron pump. Right? The electrons enter the solution through cathode. Electrons enter the solution through cathode. Electrons enter the solution through cathode and leave the solution through anode to return the battery. And leave the solution through anode to enter the battery to return to the battery. Right? Now, when current flows, sodium ions and chloride ions get attracted towards the opposite electrodes. When current flows, sodium ions and chloride ions get attracted to opposite electrodes, right? As a result of which the motion of the charged particle constitutes electric current. The motion of charged particles constitutes electric current. That's how current flows through the solution. Fine. After reaching the opposite electrodes, the ions get discharged. After reaching the opposite electrodes, the ions get discharged. Fine, we get this in here. Now let's see what is the reaction that will take place at each of the electrode. At cathode. At cathode, what would be the reaction that will take place? You would have sodium ion, which is in liquid state, would accept an electron and would get converted into sodium metal. Right? This is where my reduction half takes place. Right? These electrons are supplied, the electrons that are going to go to sodium are supplied by the battery and are accepted by sodium to form neutral sodium, right, at anode. Chloride ions will get converted into chlorine gas. 2 atoms of chlorine gas plus 2 electrons. Right? This is going to be my oxidation half. That would be your oxidation half, right? And these two chloride atoms, which are in gaseous form, would combine to form chlorine molecule, Cl2 gas. Right? So thus at anode my overall reaction will be, at anode I would have two chloride ions which are in liquid state. That would give me chlorine molecule and 2 electrons. This will be my reaction at anode. So in that case, what will be my net cell reaction? My net cell reaction, let's come to this. The net cell reaction what would be my net cell reaction? The net cell reaction would be the reduction half is multiplied. You have the reduction half, which is Na plus E gives you Na liquid and liquid, and this is my reduction half. And my oxidation half is 2 chloride ions will give you chlorine molecule plus 2 electrons. This is my oxidation half. Now the number of electrons should be same because the charge that is given out has to be equal to the charge that is absorbed. The reduction half has to be multiplied by 2 so that the electrons which are lost in the oxidation half can be gained in the reduction half. Reduction half is multiplied by 2. I'll get 2 sodium ions plus 2 electrons will give you 2 Na liquid. Right? Now add this to 2 chloride ions in liquid form would give you chlorine gas, Cl2 gas plus 2 electrons. If I add the 2, my net cell reaction will be 2 electrons on either side would get cancelled. So I'll get 2 sodium ions in liquid state plus 2 chloride ions in liquid state would give you 2 sodium in liquid state plus chlorine gas. That would be my net cell reaction that I would have. Thus, there would be a transfer of electron in the solutions from cathode to anode because it is going to be, as the 2 electrons are removed from cathode in the form of sodium atom, while 2 electrons are given to chloride in the form of chlorine gas. As a result of this, electrolysis takes place. You will get molten sodium at the cathode, and you will get chlorine gas at anode. Fine, do we get this thing here? So, do we understand the reaction that takes place? Right? Okay, we'll stop this here for today. Thank you very much.